In this lecture, I am going to discuss relation between circular and hyperbolic function. The topic is taken from a course Fundamental Mathematics of BSc first semester. This course is designed for the student of BSc first year of Degree College Uttarakhand. Now, before we over the relation, just brief about the circular functions. You all aware that if x is real number or complex number, we can define sine, cos, tan, cot, sec, and cosec. In basic trigonometry, you know that sin x is nothing but the ratio of perpendicular and hypotenuse, and the cos x is the ratio of base and hypotenuse, and tan x is the ratio of perpendicular and base, and so on and so on. I think you all are aware of these functions, and the values of cos and sine in terms of exponential function. Euler's theorem states that e raised to power ix is equal to cos x plus I sin x. Now we know that e raised to power ix is 1 plus ix over factorial 1 plus I square x square over factorial 2 plus I cube x cube over factorial 3, and so on and so on. Now e raised to power x is 1 plus iota x over factorial 1, and this is minus 1 because iota square is minus 1 and iota cube is minus iota, and so on and so on. If we separate these quantities, this expression in real and imaginary parts, that means then e raised to power x is 1 minus x square over factorial 2 plus x4 over factorial 4, and so on, plus iota into something this. So we'll see that this expression in this first bracket is nothing but cos x, and expression in this second bracket is nothing but sin x. So we can easily calculate it. E raised to power ix is cos x plus iota sin x. Now if replace this iota x by minus iota x, then we will get this equation: e raised to power iota x is equal to cos x minus iota sin x. So by these two equations, two identities, e raised to power iota x equal to cos x plus iota sin x, and e raised to power minus iota x equal cos x minus iota sin x, we can calculate the values of cos x, sin x, tan x in terms of this exponential form. So if from these two identities, if we add these two, e raised to power iota x and e raised to power minus iota x, so we will get this 2 cos x. 2 cos x, if we'll add these two equations, then cos x and cos x, 2 cos x is equal to e raised to power iota x plus e raised to power minus iota x, and if we'll divide both sides by 2, we'll get the value of cos x equal e raised to power iota x plus e raised to power minus iota x over 2. Similarly, if we subtract the second equations by this first one, then we'll get sin x is equal to e raised to power iota x minus e raised to power minus iota over 2 iota. Now we know that tan x is nothing but sin x upon cos x. That's why this tan x is e raised to power iota x minus e raised to power minus iota x from this sin x over e raised to power ix plus e raised to power minus iota x plus from this cos x. So this is tan. Similarly, we can calculate cot x, cosec x, and sec x. Now in this analogy, we can define hyperbolic function. So this function is read as hyperbolic cos x. And the hyperbolic, if x is real or complex. If x is a real number or complex number, then we defined hyperbolic function is like this. Hyperbolic cos x is e raised to power x plus e raised to power minus x over 2, and hyperbolic sin x is e raised to power x minus e raised to power minus x over 2, and hyperbolic tan x is again sin hyperbolic x over cos hyperbolic x, that is e raised to power x minus e raised to power minus x over e raised to power x plus e raised to power minus x. Hyperbolic cot x is e raised to power, this is cos hyperbolic cos x over sin hyperbolic sin x or 1 over hyperbolic tan x. So this is hyperbolic cot x is e raised to power x plus e raised to power minus x over e raised to power x minus e raised to power minus x. Hyperbolic sec x is defined as 1 over hyperbolic cos x, so that is 2 over e raised to power x plus e raised to power minus x, and cosec hyperbolic cosec x is 1 over hyperbolic sin x, that is equal to 2 over e raised to power x minus e raised to power minus x. Okay, so as we know the relation, the exponential values of sine cos, that means the trigonometric function is in terms of exponential form. So similarly we can define these hyperbolic function. Now we will find the relation between circular and hyperbolic function. As from that Euler values, we know that cos x, where x is real or complex, cos x is e raised to power ix plus e raised to power minus x over 2. Now if we replace this x by this x by iota y, then we will get cos iota y is equal to e raised to power iota square y. This is, we will replace x by iota square y plus e raised to power minus iota square y over 2. Now we know that this iota square is nothing but minus 1. That's why this cos iy is e raised to power minus y plus e raised to power y. Again this minus iota square is 1 over 2, and this is the definition of hyperbolic cos y. So we'll get this cos iota y is equal to hyperbolic cos y. Okay, now next, this sin x is e raised to power iota x minus e raised to power minus iota x over 2 iota. If we replace this x by iota y, then we will get e raised to sin iota y is e raised to power iota square y minus e raised to power minus iota square y over 2 iota. Again iota square is minus 1. That's why sin iota y is equal to e raised to power minus y minus e raised to power y over 2 iota. Now this is minus of sin hyperbolic sin y. We know that hyperbolic sin y is e raised to power y minus e raised to power minus y. Take the minus common, is minus sign is common, then we will get this e raised to power y minus e raised to power minus y over 2 is hyperbolic sin y, and I is left, and so this expression is equal to minus hyperbolic sin y over iota, and we know that is minus 1 is iota square, iota and iota is cancel out, this is iota sin hyperbolic sin y. So the sin iota y is equal to is equal to iota sine hyperbolic y. Similarly, for 10 iota y, 10 iota y, we know that 10 theta is equal to sine theta over cos theta, or 10 iota y is equal to sine iota y over cos iota is sine iota y over cos iota y. This is, by the simple calculation we can calculate this 10 iota cot iota y. You know that cot iota y is equal to 1 upon 10 iota y equal 1 upon iota 10 hyperbolic y, because we know 10 iota y is iota 10 hyperbolic y. If we'll, this 1 is minus iota cube, this 1 is, sorry, this 1 is iota raised to power 4, this iota and iota raised to power 4, one iota will be cancelled out, this is iota cube, and iota cube is nothing but minus iota. That's why this cot iota y is equal to minus iota y. Next, sec iota y. Know that this sec iota y is 1 upon cos iota y. This is equal to 1 upon hyperbolic cos y, because we know that cos iota y is hyperbolic cos y, that is equal to sec hyperbolic sec y. The last, cosec iota y is equal to 1 upon sin iota y, and this we know sin iota y is hyperbolic sin y, and again this 1 upon iota is minus iota, and 1 upon sin hyperbolic sin iota is cosec hyperbolic iota. So these 6. Now on the basis of definition of hyperbolic functions and circular functions and relation between them, we can handle some questions and establish some formulae. The first formula between hyperbolic function is hyperbolic cos x square minus hyperbolic sin x square is equal to 1. So this formula can easily be calculated by putting the values of these hyperbolic cos x and hyperbolic sin x in terms of e raised to power x. So we know that hyperbolic cos x is e raised to power x plus e raised to power minus x. Relations between minus, okay, sorry, the whole square of this expression minus e raised to power x minus e raised to power minus of this one is e raised to power 2x plus e raised to power minus 2x plus 2 over 4, and whole square of this quantity is e raised to power 2x plus e raised to power minus 2x minus 2 over 4. Now by calculation we can see that the terms e raised to power 2x and e raised to power 2x will be cancelled out, e raised to power minus 2x and e raised to power minus 2x will be cancelled out, so we'll get only the value 4 by 4, that is equal to 1. Okay, now similarly for the second formula, we'll put the value of hyperbolic square cos x square and the value of hyperbolic sin x square. The value of this is e raised to power x plus e raised to power minus x minus x divided by 2 to power x minus e raised to power minus x over 2 whole square of this quantity. Now on solving, we'll get this is e raised to power 2x and e raised to power 2x terms will be added and we'll get this expression is equal to e raised to power 2x twice of this 2 e raised to power 2x and plus twice of e raised to power minus 2x 2x over 4. The term plus 2 from here and minus 2 from here will be cancelled out. Now if we'll take 2 is common from these two terms, so we'll get this is equal to e raised to power 2x plus e raised to power minus 2x divided by 2. This is nothing but hyperbolic cos 2x. So this is the second formula. Similarly, we can calculate the value of hyperbolic sine 2x and this last one relation. So thank you. Hope you enjoy this lecture and you now I think you are able to handle the questions of circular and hyperbolic function. For any queries, if you have any queries, you can contact me on my mail id. My mail id is matpal.p mathpal.p @gmail.com, and you can WhatsApp me on my WhatsApp number. My WhatsApp number is 9410141973. I am repeating my email ID again, mathpal.p @gmail.com. Thank you. Have a nice day.